All right, so let's look at this problem. The coefficient of static friction between hard rubber and a normal street pavement is about 0.9. And you are asked to find what is, or how steep, the maximum angle then you can leave your car parked on. So for that, first of all, let's put what is given. So it's mu, and it's mu s, it's 0.9. And you are asked to find theta max, such as your car doesn't move. So the first thing that comes to mind, you have to think that this is going to end up being a problem of static equilibrium, right? However, just for practice right now, let's draw an inclined plane and define all our forces. And so by doing so, we're going to be able to write Newton's second law that applies for this particular example. And having the equations, you're going to be able to actually find out what is this angle. This is a very classic problem. So let's start by refreshing our memory how we draw all the vectors here. So first you have the weight. So here it is. I'm going to choose to just go with mg as a vector this way. And then the second thing you want to do is draw a parallel line. Let's make it gray here so it's easy for me to. So you make a parallel line with a plane. So that will be your x-axis, and one that is perpendicular to it, that would be your y-axis, right? And now we can actually draw the components. Normally you wouldn't have both of them on a three-body diagram, but I think it's great practice. So what are we looking for here? We're looking for this theta. And let's see how do we find the theta, because that's one important part. So you may remember from geometry that angles that have corresponding sides being perpendicular, the angles are congruent. So let's look at this for a moment. The base of your plane here, I'm highlighting yellow. It's perpendicular to the direction of the weight vector. So that defines the angle theta, one of the sides of the angle. Now I'm going to highlight with a different color. Let's say this is green. I'm going to define the other side of my angle theta. Now that is perpendicular to the y direction. So that kind of shows you that the two angles that they have the corresponding sides perpendicular creates the angle. So this is how you find your angle theta in an inclined plane. Yeah. So now if your car is parked, obviously it's in a hill. Normally, if the car will not stay, right, it will go downhill. So the friction force is opposite to the motion. So it will be going uphill this way. So let's call this our force of friction. Okay, now we have a normal. Remember, the normal is perpendicular to the surface. So our surface here is under an angle. So here it is. It's perpendicular to the surface. So we'll call this F normal. And this will be normally it. Yeah. But what I want to show here, and do a little refresher here, is how do you find these components? So here you just kind of close your parallelogram. Well, in this case, it's a rectangle, right? So you have this component of the weight on the y direction. And if you look, it's the adjacent. So this would be your mj cosine of theta. Yeah. And then you will have the x component, which is obviously if you look in a triangle, right, it's the opposite. So there will be a sinus, mj sine of theta. Very good. Okay, so let's look at how do we set up the equations. Now we have what we're looking for. So as I mentioned verbally, so the friction force is opposite to the direction of movement, which would be actually downhill. So what is Newton's second law telling you? Remember what kind of equilibrium you have here, right? The car is supposed not to move. So the sum of all forces, so you do that for each component on the x direction, should be equal to the mass times acceleration on the x-axis. And we'll talk about each one separate, right? Then the sum of all forces on the y direction. So that's the net force on the y direction will be the mass of that object. I'm going to put this as an M right there. Times the acceleration on the y direction. this will produce a system of equations that you actually go about and solve it. Now, let's talk about our case, right? So in our case, the car is not moving, and on the x direction, which we have right here defined, this is your x direction. I'm drawing it here with red. This is my x, and this will be your y. And I kind of define by doing so which way it's my positive direction, right? But because it's not moving, this acceleration is 0. I'm going to put this in a parenthesis for you guys, so not moving. Okay, cool. Now let's see what's happening on the y direction. But this car doesn't doesn't go up and down. It's not flying up or down or anything. So obviously this acceleration on the y direction, this will also be 0. So not going up or down. Okay, so now that's squared away, we can actually pick up and write down our equations for this case. And then you also have, don't forget, what is the definition of the friction force? So that would be our third equation. Friction force is defined like the coefficient of friction times the normal force. So if I'm to kind of dot this up, this would be one equation, second equation, and your third equation. Oh, sorry. Second equation and your third equation. All right. So let's look at what we get here. Let's look on the x direction. Right, so the one that goes in a positive direction, the way I chose it, is the x component of the weight, which is mg sine of theta. So this produces the following, mg sine of theta. Yeah. Then the force of friction is going opposite way, so it's minus force of friction, and that's equal 0. So that is what your first equation is producing. Second equation, the sum of all forces on the y direction. So on the y, I have the normal force in a positive direction, right? Minus the y component of the weight, which is mg cosine of theta. And that will be equal to 0. So that is what the second equation becomes. Now I'm going to write a third equation just so I have it. Force of friction is equal to mu Fn. Okay. So this is a system of equation, and then you have to pay attention to what you are asked to find. Because they give you mu, right? And then you have the mass. Actually, you don't have the mass, but you will see what happens to it. Now your job is to find theta. So I am going to actually highlight what are we looking for. So we're looking for anything that contains theta in here. So we have plenty of equations. You have 3 equations and 2 unknowns. And let's see how do we solve algebraically this. So the first thing I'm going to do, where the force of friction appears, which is mu Fn, yeah, I'm going to plug it into where it's supposed to be. So that becomes mg sine of theta minus mu Fn equals 0. From the second equation, I will separate what Fn is. So the normal force is mg cosine of theta. Yeah, so that one, I'm going to plug it into here. So this is by substitution, yeah, in a way you substitute and you eliminate, but you don't do an elimination, a pure elimination method. So now from these two, you put them together, yeah, you marry them, and you get mg sine of theta minus mu times, instead of Fn, now you have mg cosine of theta, and that is equal to 0. So as you can see now, I am getting an equation here that involves mu and the sine and cosine. As you can see, I can move one of the terms on the other side. I'm choosing here the one that has a negative sign in front of it. I'm adding it on both sides. So mu mg cosine of theta. As you can see, you divide with mg. In other words, this mg goes away, right, for both. And look what you get. You divide by cosine, and you get mu is sine of theta over cosine of theta. Oh, so I can write that my mu is nothing else but tangent of theta. This is definitely a very classic problem, and this is for your maximum angle. Yeah, so if the coefficient of friction is equal to the tangent of the maximum angle, your car will actually stay parked. However, we're not done. We are asked to find here the theta by itself. So that will be inverse tangent in your case. So tangent minus 1 or arctangent, whichever way you like, of mu. So that is how you find this theta that you need. Of course, then you can plug in your numbers and get your calculator ready. Tangent minus 1 of 0.9. All right, so let's see what this produces here. Okay, so 0.9. 41.98 degrees. Well, you can round it to 42 degrees roughly, yes? So for this particular exercise, your maximum angle should be 42 degrees. All right, I hope this helps.